So what we're doing today is something that you guys asked about. Welcome, Lydia. Welcome. Uh, welcome. I wish I could say y'all name. Chase. Welcome. So what we're doing today, we're gonna move on and do this part today, guys. And I think some of you guys asked about 30, 60, 90 triangle, and I wanted to see if I could find a way to help you guys with 30, 60, 90 triangles. And we're gonna answer some questions that you guys have about this today, and then we're gonna call it a day. Let's see. If you were able to see the screen on on YouTube, let me know as well. So I'll tell you guys what I did, and you probably noticed that I show uh, dash welcome. Let me double check that everything is is set up properly. All right, cool. I think it is. I think my screen is sharing. Let's see. Yes, I think it's set up properly. All right, good. All right, guys. So here's the deal. Uh-oh. I don't know why it's going this way. So here's what I did. I tried something new today. I'm trying to do backdrop. So I'm gonna get an official backdrop because I think, as you can see, you probably able to see me a lot clearer than the past few months. Because I didn't know using a white background was the most terrible idea you could have for a backdrop. So now I'll be using something that's can reflect, either black or a different color, so that way that you can see me better. So today we're gonna talk about 30, 60, 90 triangle. Hey, how you doing, Mateo? I'm doing well. How are you? Um, who else can? Kunzi, what's going on? Judith, what's up? Um, Naby, what's up? Raquel, hi, 39. What's going on? Welcome back. Good to see you again. All right, cool. So, if you want to see the screen, the best way to do that is to go to YouTube and type the Jax Tutor. You'll be able to see the screen, and you'll probably see me a lot better than than what you normally see. So we're gonna try an official backdrop because this looks a lot better than what we normally have. All right. So what's going? Hey, how are you? I hope everything is well. I haven't seen you. I haven't seen you back here in a while. So, guys, let's look at the screen, and I'm gonna give you guys some example. Let's make this kind of official and use some of the tools that this has. Since we haven't used them in a while, let's use an actual triangle. So we're gonna use an actual triangle, a right triangle, but let's make it look like it's a 30, 60, 90 triangle. So what that means is, as you guys know, is one side of it is one not side. Let me make this actually a little bit bigger, so that way we can explain what we try to explain a little bit better. All right. So this is probably going to do it. So let's pretend that this is a 30, 60, 90 triangle. What do we mean by that is this angle, the smallest angle is 30 degrees. This angle right here is 60 degrees. And then this right here is the right angle, or aka 90 degrees angle. So now, knowing this, we're going to try to find the length of certain sides. We're going to find the relationship between the length of each side of the triangle. And this is what we're going to do today. And I know this is one of the questions. Sandra, welcome. I know this is one of the questions that you guys asked, and I wanted to see how I can best explain it to you all so you can understand what exactly does a 30, 60, 90 triangle involve. So the first thing that we're going to do is let's start with an easy problem. Let's name the length of the smallest side. Let's name this x, for example. For example, if we name this x, so if we want to know what's the length of the hypotenuse, what's the length of this? So let's give this some names: A, B, C. So we know the side BC, the length of BC is x. And the length of AB, we don't know. Let's call this one H for hypotenuse. Let's call this one Y since we already have an X. Now, according to Pythagorean theorem, I failed my math 3 times in high school. Man, sorry to hear that, man. Well, I hope you found some help. According to what to Pythagorean theorem, we know that when you have h squared plus h squared is supposed to be equal to the side of x squared plus y squared. Now, if we find a size that doesn't, that doesn't obey this rule, or that violate this theorem, for example, that means can you show the triangle? Sandra, you got to go to YouTube and type the Jax tutor, and you'll be able to see the screen. I don't think Instagram has that feature where you can show the screen on there. So if you're on there, you got to go to YouTube so you can see the screen, and you'll be able to see the screen. Just type the Jax tutor on YouTube, and it'll pop up, and you'll see me live. So if this was a recording, I would have showed you the screen, but otherwise you gotta go to hey, what's going on, Chris? Hey man, I hope all is well with you as well too. So now if we find the length of those sides, we need to make sure that it doesn't violate this theorem. So here's what we're gonna do. We're gonna and usually this is one thing that if you remember this, it will save you a lot of time when you're doing this, depending on what class you're taking. You might ask you to prove this, or they might ask you to they might give you one side and ask you to find the other one. If they do that, if they give you the smallest side x, this side right here that we call y, there's a formula to find it, and this one right here, there's a way to find the hypotenuse. So if we know the length of the smallest side, which is the one that is facing the 30-degree angle, and what I mean by facing is directly opposite to this, so to this 30-degree angle. If we know that side is x, all we have to do to find the hypotenuse is just multiply this by 2, and that would be 2x. And the same thing too, if we know this side is y, all we have to do to find the length of this side is multiply that x by square root of 3. Now, okay, so now does that violate the Pythagorean theorem? Let's check, right? Let's check. So what I'm saying here is x 2x squared would be equivalent, so that means the length of the hypotenuse squared would be equivalent to x squared. And then what's y equals to? Y is going to be x square root of 3, correct? X square root of 3 plus x times the square root of 3. Now, squared here and squared here. Don't forget to put that. So now, how do we make sure that this is the case? So if this left side right here is equal to this right side right here, if this side is equal to this side, that means that means we can use that fact. And it's I mean, if you want, like in high school or middle school and stuff, they probably want as long as you know that the length of the side, if you get the length of the smallest side, the length of the other side, the relation between the length of the smallest side to the length of the other side is one of them is square root of 3 times x, the other one is 2 times x. How do you remember that? Well, Square root of 3 is smaller than 2. So the ones that's 2 times x needs to be the hypotenuse. But the length of x is the length of two sides. And we're going to do different examples where you won't get the length of the smallest one, and you'll be asked to find it. So what is so what we're looking for here? 2x squared would be 2 squared is 4, x squared is x squared. And in this case, you have x squared plus, what is the square root of 3 squared? Square root of 3. If you square that, that gives you 3, right? Square root of 3 squared is 3. So now we're going to put 3 here. 3. And then you have x, you're going to square the x, which is x squared. So now what I did here, I have two numbers that one multiplied by another one, kind of like I had 2 times 4 squared. I squared the 2 and I squared the 4. That's what I did here. I squared the square root of 3 and I squared the x. So that gives me what? X squared plus 3x squared. X squared plus 3x squared. What is x squared plus 3x squared? Is 4 of those x squares. So 4x squared equals 4x squared. Now that means that doesn't violate the Pythagorean theorem, and we also say that the length of the longest side is 2 times x. So this is a pretty decent thing that we can use to find the length of any sides of a triangle. This is a good relationship that we can use to find the length of any side of the triangle, if of a 30, 60, 90 triangle, if we have the length of the smallest side. So now let's start with an easy problem, and we'll probably gradually move on to a problem that's that's a little bit harder. Math, welcome. Math. I'm trying to give you. I think it's math. I don't know how to pronounce that. Kocum. What's up? All right, cool. So now here's what we're gonna do. I gotta give you guys a triangle, and let's pretend that this is a 30, 60, 90 triangle, and we have this is a right angle. This is 30 degrees, and this is 60 degrees. And we want to know how to find the, so we have, let's say we have x here is equal to the length of the smallest side is equal to, let's say x is the length of the smallest side. Let's give them some name. A, B, C. And we know the length of the smallest side is, for example, x is equal to let's do 5, for example. So now we could do 3 too. So now we have the length of the smallest side is 5, and we want to know the length of the other side. So now here's the deal. They didn't have to put the 30 here, the 60 here, and the 90. So if they tell you you're inside a 30, 60, 90 triangle, they could have erased those angles. So what you need to know is, whatever side is facing the 30, is directly opposite to the 30-degree angle, is going to be the shortest side. And this is going to be the smallest angle, smallest side and smallest angle, directly opposite to each other. And the 60 degrees, the other leg, the longer leg, is going to be, facing the 60-degree angle. And a right triangle, the right angle is going to be directly opposite to the hypotenuse, if you want to call it that way. So now we have one of them is 5, and how do we find the hypotenuse? How do we find the hypotenuse? H, let's call it H. The hypotenuse is 5 multiplied by 2, based on what we just said earlier. So H is equal to 10. Easy, right? Now, how do we find the other side? So we have this side right here we want to find. So how do we find the other side? So let's call this side, it's AC. It's the length of AC. How do we find the length of AC? We said 5 multiplied by the square root of 3, which is 5 square root of 3. Now, that's good. Okay, let's make sure that we can Good job, Sarah. Yeah, that was 10. Let me show. How do we find? So how do we know that this is right? Let's verify. There are many ways that we can verify it and say, hey, um, let's make sure that what we did is correct. So yeah, so 5√3. Now let's see. Now we can use the same thing that we did earlier. Let's use for example, let's use the Pythagorean theorem to see if what we did is right. Let me use a different color for no reason at all. So Pythagorean theorem say the hypotenuse, which is AB, and I'm gonna move this up so you can see the hypotenuse is AB. So what it says, AB squared should be equal to AC squared, which is the length of this side, plus the smallest one, plus BC squared, which in this case we called it X. Now let's see how that works out. So for AB, for the hypotenuse, we found 10, and this 10 was right here. 10, and that's 10. That's what we found for the hypotenuse. For AC, we said it was 5√3, 5 square root of 3. We're going to square that. Okay, let's see if we made any mistake at all. And then for BC, which is this guy right here on the left, for BC, it's 5 squared plus 5 squared. All right, so now 10 squared actually. Okay, so now is that true? Okay, let's see if that's true. So what's 10 squared? 100? 100. And what is 5 squared times 3 squared? We're going to do the same thing that we did earlier. So we're going to square the 5 squared. And then we're going to multiply by square root of 3 squared, which will give you 3. So what you did, you could square the 3, which is 9. You take the square root. Or you could say square root of 3 squared is 3. Plus 5 squared. Okay, let's do some calculation. So so on this side we have 100. On the right side we need to end up with 100. What is 5 squared? 25. Plus, what is square root of 3 squared? Like I'll multiply actually. Multiply by what is square root of 3 squared, which is 3. And what is 5 squared again? 25. So what do we have? 100 is equal to 75 plus 25. And 75 plus 25 is equal to 100. So therefore, now according to Pythagorean theorem, what we did is correct. So how do we thank you, I appreciate you, Sandra. So how do we what if we have other sides and we want to find let's say we have the hypotenuse and they tell us it's a 30, 60, 90 triangle. We have the hypotenuse and we want to find the length of the longest leg. So okay, Nicole, welcome. So we have the hypotenuse and you know it's a 30, 60, 90 triangle and you want to find the length of the longest leg. So how do you do that? It's the same thing. Let's draw a different triangle, a purple triangle. So we have the hypotenuse. Let's say we know the hypotenuse is, let's pick a nice number. Let's say we know the hypotenuse is 20, for example. And we know it's a 30, 60, 90 triangle. It tells us this angle is 30. It tells us this is the right angle. And that means this angle is 60. And we want to find the length of the longest leg. Let's call it Y to say consistent with what we're doing. And we can name those A, B, C as we want so they can have names. So now, how do we find the length of the longest leg? Angel, welcome. Jessica, welcome. Blanco, welcome. Skillet, welcome back. Okay, so now we have, if you guys want to see the screen, go to YouTube and type the Jax Tutor. The screen will pop up and you'll be able to see everything. And you can see all the previous sessions live that we had in the past year or so. So, okay, we have 30. One angle is 30. I mean, one angle is 60. So that means it's 30, 60, 90 triangle. And we want to know the length of the longest leg, knowing the fact that the hypotenuse is 20. Now, here's one thing that I like to do. If you don't want to memorize a bunch of formula, you can always go back to the smallest leg, and then from there, you go where you want to go. So what I mean is you have the hypotenuse. Based off of that, I can find the length of the smallest leg, small leg. And then, because I know the small leg, if I need to find something else I know all the relations between the small leg and the other stuff. I can just find the length of the side that I want, and I'll do an example, this example, so you understand what I'm saying. Let me see if you guys have any questions. Questions? Yes, no, maybe. All right, no questions so far. Cool. So, I have this 20. So to find, the length of, so we know the relationship between the hypotenuse and the length of the smallest leg. So we know the relationship. The hypotenuse, h, let's call it h, is equal to twice the length of the smallest legs. So that means 20, which is the length of the hypotenuse here, is equal to 2 times x, because that's what they tell us. Bryson, welcome. Mada Moha. I know I messed up your name. If you guys want to see the screen, go to youtube.com and just type the Jax Tutor. You'll see the screen live, and you'll have a bunch of sessions too from a year and a bunch of videos, full complete videos of math tutoring that you can use for any class that you've taken, any math class that you've taken. All right, cool. So now we have the length of the longest leg, and we have the length of the hypotenuse. We want to find the length of the longest leg. So what I said, so the easiest way for me to do it myself is going from where we at to the smallest leg, because I know the relation between the smallest leg and all the other legs. So what I'll do is go from what they give me to the smallest leg, and then I'm going to go from the smallest leg to what I need. Okay, so this is 20x. 20 is equal to 2x, and I divide both sides by 2, and I find that x, which is the length of the smallest leg, is 10. Now, what do we need? The longest leg, and we know the relationship between the longest leg and the smallest leg is just 10 times square root of. It's just whatever the smallest leg is times square root of 2. So that means y, and you can see it here. I don't want to. I want you to know I'm not coming up with those names. Y, and that's what I name it. Y is equal to, just like we said earlier, y is equal to the length of the smallest leg, x multiplied by square root of 3, and that's what it's always equal to. So now what we're going to say is y is equal to x, which is 10, multiplied by square root of 3. 10 square root of 3, and that's it. Now, we can always prove to see if that's right. So what we would need is 20 squared is equal to 10 square root of 3 squared plus 10 squared. And is that the case? 20 squared, 400. 10 square root of 3 squared is 300 plus another 100. So 400 is equal to 400. That means what we did is right. And this is a quick way to prove what we did is correct. All right. So now let's go from a different perspective. Let's say now that we have the length of the longest leg, and we need the length of the hypotenuse, for example. So if we have the length of the longest leg and we need the length of the hypotenuse, let's do another triangle. Now, I'm probably going to trick you guys. Let's do another example. You guys have any questions first? Question? Yes, no, maybe? All right, cool. So let me scroll up and try to do something similar to that. Let me change color for no reason at all. All right, cool. So let me put another triangle here. And this time around, purposely gonna try to confuse you. Let's do a triangle this way. Let's face it this way. So the right angle is right here. And this is the 30-degree angle. I wish you guys could react, I wish I could have you guys on video because it's easier when you're teaching somebody. You can say, hey, questions, they'll tell you exactly. But I think it takes some time for me to see the questions and go back to it. But that's fine. If you have any questions, you can ask. 60 degrees angle, 30-degree angle. So now we have the length of the longest leg in the triangle, which is here. Let's call this one L, for example. And the names don't have to be the same. Whatever I'm calling X here in your class, that may be the hypotenuse. So it's just understanding the relationship. The notations doesn't really matter that much, as long as you stay consistent. All right, cool. So let's go L. This is L, and this is the length of the hypotenuse. And I like using H for hypotenuse. And then we have the length of the. We want to know the length of the shorter of the hypotenuse. So let's say we have L is equal to 15, for example. So we know the length of this is 15, and we want to know the length of the hypotenuse. Now, like I say, we're going to do this the same way. We don't have to memorize a bunch of formulas and say, hey, this is 2 square root of 3 times this. No, we don't have to memorize that. If we understand it in a way, in a mathematical sense, it will make it a lot easier for us. So all we need to know is the relation between the length of the smallest side and the other side. So we know the relation between the length of the smallest side, which is x, and the length of the longest leg, the smallest leg, and the length of the longest leg. What is it? What's this relationship? L, the longest leg, is equal to the smallest leg, x, multiplied by square root of 3. And that's the relationship that we know. And because we know this relationship, now we can go from that longest leg to the smallest leg, vice versa. Now they give us the longest leg. What they ask us is the hypotenuse. They give us the longest leg. They ask us for the hypotenuse. But we know the relationship between the longest leg and the smallest leg. We also know the relationship between the smallest leg and the hypotenuse. So we're going to go from here to here. And then from there, we're going to go to here. See? Well, I always try to go back to the smallest leg. So if I had this, I would go from here. And I'll show you, this is what we did in the previous video. We went from, in the previous example, I would say, we went from, I had the hypotenuse, I went from the hypotenuse to the shortest leg, and from that to the leg that they were asking me for. And makes it a lot easier. Let me see. All right. Welcome, guys. If you just come in, just as you come in, say hello and welcome. So you see, I went from the hypotenuse to the smallest leg, and from the smallest leg to the longest leg. And it's easy. It makes it easier for you, and you can do it that way, and you don't have to memorize a bunch of formulas. So now I already know the longest leg. All I have to do now is saying, okay, I know the longest leg. I'm going to go from that to the smallest leg. Ooh, my phone is down. Okay, I'm going to go from that to the smallest leg, and then from there, I'm going to find the hypotenuse. So how do we go from the longest leg to the smallest leg? This is the relationship, right? So L, the longest leg, is 15, x square root of 3, right? And I divide both sides by square root of 3, square root of 3, square root of 3. That gives me, this square root of 3 here is gone. That gives me 15 square root of over square root of 3. Usually when you find something divided by a square root of a number, you can rationalize and just multiply both top and bottom, numerator and denominator, by square root of 3. So I can multiply this by square root of 3 and multiply this by square root of 3. That is not, I don't want to say it's not really necessary to find the answer. You can do it at the end if you end up with something at the bottom. But let's do it now. So what we have, so that would give us 15 root 3 over 3. 15 square root of 3 over 3, which is what? 15 divided by 3 is 5 square root of 3. All right, guys, you're going to help me with this. So now I have the length of the smallest leg. So I have the length of the smallest leg. How do I go from that to the hypotenuse? I just 7, welcome. And Villegas, welcome. So how do I go from the shortest leg to the hypotenuse? I just multiply by 2 because it's a 30, 60, 90 triangle. So from there, I would just multiply this guy, 5 square root of 2 by 5 square root of 3 by 2, and that means the length of the hypotenuse is 2 times this guy, which is 5 square root of 3. And that gives us what? 2 times 5 is equal to 10 square root of 3. Now, 10 square root of 3. All right, let's see if what we did is good. So if what we did is good, 10 square root of 3 squared should be equal to the length of the other side squared. So the hypotenuse, 10 squared, nope, 10 square root of 3 squared should be equal to 5 square root of 3, which is the length of the smaller side, squared, plus 15 squared. Okay, let's do some math. Yeah, we started with 15. The longest leg was 15. I'm going to show you guys again. The longest leg was 15. We went from the longest leg to finding the hypotenuse. And the shortest leg, which was 10. 5 square root of 3. And then from there, we went to find the hypotenuse, which was 10 square root of 3, because all you had to do is multiply by 2, right? All right, so let's see if we, so let me see. Double check, divided by square root of 3. All right, cool. So 5 square root of 3, 10 square root of 3. Let's see if that's the same. All right, so 10 squared multiplied by square root of 3 is 10 squared multiplied by square root of 3 squared is 3. In this case, what we have, 5 squared multiplied by square root of 3 squared is 5 squared times 3. I'm just putting 3 for all of those, plus 15 squared. So 10 squared is 100 times 3 is 300. 5 squared is 25 times 3 is 75. That's 75. 5 squared 25, multiply that by 3 is 75. And what is 15 squared? 15 squared. I'll take my calculator. 15 squared is 225. Okay, is 225 plus 75 300? Is that the case? I think so, right? Add 75 to that. That gives me 300. So 300 is equal to 300. So that means what we did is right. So now, from now on, you shouldn't have any questions that about 30, 60, 90 triangle that you can't solve. So all you have to do is, don't get it complicated. All you have to do is go from what you have to the smaller side of the triangle. From there, you go to what you're looking for. And if you already have the smaller side and they ask you for another side, and that's an easy question, you just multiply by square root of 3 if they ask you for the longest leg, or you multiply by 2 if they ask you for the hypotenuse. And that's all you have to do. So anytime that you watch this video, anytime that you have a 30, 60, 90 triangle question, you can watch this video and see how I do it. And the simplest thing to remember is just, you really don't have to memorize a bunch of formulas, as long as you know the relationship between the smallest side and of the triangle and the hypotenuse, or the longest leg, and you should be fine. All right, so guys, thank you. I think this is it for today. Yeah, I see some of you guys online. Thank you. I appreciate you coming by. I think this should do it for today. Madison, welcome. Bayla, you missed the party as well. So this should be it for today, guys. Welcome, and I look forward to seeing you in Alina wanted an example of simplifying radicals. I will. I'm gonna. Here's what I'm gonna do. I'm gonna put that in the note for you, Alina, and this is gonna be one of the topics that we talk about next time. Let's see, simplifying radicals. Let me go simplifying radicals. I think this is one of the upcoming topics too. Let's see if I have that on there. Simplifying radicals. No. Radical expressions. Okay, maybe simplifying radical expressions too. Simplifying radical expressions. So this is in the queue, Alina. So radical expressions. Radicals. So Alina, this is in the queue. So we'll go over that once we get into through it. So I think this should help you guys with the 30, 60, 90 triangle. And Alina, I put your question down. So whenever we're going to go over each one of them, and this is your question will be one of those that we answer. All right. Any other questions, guys? Yes, no, maybe. All right. I think this is it. I'll catch you guys another time, and I appreciate you coming by. Thanks. Bye. Thank you. No problem. I'll take the SAT tomorrow, but I can still join. Yeah, we'll be here on Tuesday. We'll be here Tuesday, Alina. Yeah. Hey, good luck on the SAT, by the way. Hey, get some sleep too, man. It's like 10 o'clock. I don't know what time you're taking it, but get some sleep because one of the things that I like to say is, when it's that, you're welcome, Katie. When it gets to, when you get to one less than 24 hours until you take the exam, there's not really much that you can do to really change your score. You can do a review, but sometimes you're gonna need some sleep too. Yeah, get some sleep, man. You're welcome. Good luck. Let me know how it goes. When you come back, let me know how you did. Hey, we'll celebrate you if you did well. Let me know how you did. All right, cool. Thank you guys. I appreciate you all coming by, and I will see you. You're welcome, Katie. I will see you guys another time. Do you mind talking about trig with non-right triangle real quick? Okay, so I think what you're referring to is the law of sine and law of cosine. We can put that in here. I actually have a law of sine and cosine. So Katie is referring to is I think what you're referring to, Katie, is like sine and cosine. Is more like the generalized case of the Pythagorean theorem. So that means when you don't have a right triangle, how do you find one side, and if you have an angle, how do you find the other side? Yes, that is what I think you're referring to. Yes. So I'll put that in there, and then when we'll talk about it. Now, is that something that you have, Katie? Is that something that you have an exam on, or something that you're doing a review on? Because what we could probably do is, I don't know, just escalate it. Maybe next time I come, I'll just prepare some stuff and just talk about that, and along with the other topic that we're gonna talk about next time. Is that something that you could have an exam on? Yes, it's on Friday. Uh-oh. Shoot. Let's see. Okay. Let me see. Katie, I honestly don't think I have a video on there. So here's what I'll do. An exam. Okay. All right. So here's what I'll do, Katie. Now you're gonna hold me to this. I will find some examples and make a video for you and post it on. So if you're on TikTok, you'll see it. Your Instagram, wherever you at, YouTube. Maybe I might post the longer version on YouTube, like where it's everything's on it. On TikTok, you'll get like a snippet, but YouTube is probably where you can find the longer version of that video. So what I'll do is find some example of law of sine and cosine, and then do a video on it. Let me see. It's Friday. All right, cool. All right, give me by. Okay, she said don't worry about it. I just really like how you walk through things while explaining a problem. Yeah, thank you. I appreciate you. I can do a video for you, Katie. I'll be honest with you. I can do a video for you. I'll do a video maybe on each one of the laws, and do a video of each and explain it to you. Go to I would say go to YouTube and see it. So what I'll do is just go do it and then post it on YouTube. You'll be able to see it there. On TikTok, you may not see the whole thing. If I posted like a little short, you know, clip of it, you won't be able to see the whole thing. But I'll find some examples and explain it to you. Well, I want to find some examples that they normally use for kids. Are you in like algebra? Thank you all my friends use you for help, so we are really appreciative. No problem. Thank you. Thank you. Okay. All right. So I'll find something. I'm gonna try to find something and post it by this time tomorrow. Give me about 24 hours. I'll find something and post it by this time tomorrow. So I'll find some stuff and then record a video and post it by this time tomorrow. I don't think I have any law of sine and cosine. That's why I don't tell you go to my channel and type law of sine, because that would pop up if I had some video of that. And okay, precalc. All right, so I'll find some video on law of sine and cosine, and do a video and then post it for you on YouTube. But you got to go to the YouTube channel to see it, and that way, hopefully that helps. One on each law. Hopefully that helps in your exam. So when it comes up, you know what to do, if that makes sense. So give me by this time tomorrow. Okay. And then if I post it, yeah, no problem. If I post it, what I'll probably do is do I would check the channel, the YouTube channel. If I post it beforehand, and I have time to create like a short clip, what I'll probably is post a short clip on here so you can see it, and that way that'll alert you that there's a longer video on YouTube. Okay, Katie. Yeah. So law of sine and cosine, and I'll write your name on here. So I'm gonna work on a video and maybe two of them and post them so that way that you understand. Hopefully that helps. All right, no problem. All right, cool guys, and welcome everybody who comes. And I will catch you guys another time. Thank you all for showing up. Alona, I hope you get some sleep and good luck tomorrow on the SAT. All right, guys. Thank you. This is it for tonight.